Okay, good morning everybody. So today we will continue on our discussion with the standard template library. We said that we are going to look at three things. Iterator, that is the generalization of the pointers. The containers itself, like the vectors and lists. And the generic algorithms that run on these containers with iterators. Yesterday actually we made a good introduction to iterators. We talked about them and we said that we like to use pointers on any kind of container data structure that contains elements, and to be able to use it, they have invented this idea of iterators, which work like the pointers. All you say is, let's look at this example again. Okay. So you say that I have a list, I have an object named container. It is type as a list of integers, a linked list of integers. And as you know, there is pushback operation for the list. I have pushback for integers in it. And I say that I have an iterator, P or P1, doesn't matter, okay, of type iterator of inner class list int, and I am initializing it with container.begin, and I continue incrementing it until it becomes container end, okay. And like a regular pointer, I use the plus plus operator to increment it, to iterate over the elements, and I use the dereferencing operator. So they have overloaded, okay, they have overloaded all types of operations, or the operators for the iterators, for all the operators available for the pointers, okay. Whatever available is pointer, they have overloaded it for the iterators. So that's the idea. So anybody reading this code, especially this part and this part, is very familiar with the operations, as long as they know what pointers are, okay? With the introduction of this auto keyword in C++ 11, I don't have to remember this notation. Line 19 doesn't make any, I don't have to memorize this line 19 anymore. Well, it is not a matter of memorization, it is a matter of just typing lots of stuff. I don't have to type it. All I say that, okay, I am going to start from the beginning of this container. Type of P is automatically deduced, and I am going to increment it until I hit the end of the container iterator. Okay, so do the same thing with this modification. Do the same thing again, the displaying of it. No problems. So this will work. This will work for all kinds of containers, and I showed you yesterday. I think it was somewhere. Okay, so go to the C++com and look at this. Okay, maybe you're not seeing it in the class. This guy is making me nervous. Turn that off. Okay. So did you know that these curtains were black? Were they really black? Did you know that? Both sides. Are they new? Were they all black? Nobody realized it? You guys are my students, right? Yeah, okay. I am not sure. I am not, because it is dark outside. Maybe I am dreaming or something. Okay, so containers, let's look at the containers. So we have some familiar containers like like the vector or the list, okay? So whichever you look at, okay? For example, let's look at the list container. Inside the list container, I have, where is my list? Inside the list container, okay, I'll have all kinds of functions, okay, and begin and end are there, okay. So begin and end they return just two iterators, or the pointers, if you like to call it, that points to the beginning and the ending of the container. We looked at this R begin and R end. R begin is the begin for the reverse iterator. It points to the last element of the container, R begin. And R end is used for the determining the end of it. So if you get a reverse iterator using this R begin, it will go backwards if you do this incrementation plus thing. So this one is a C++ addition, C begin, C end. It returns a constant iterator, okay? If it's a constant iterator, then you cannot modify that object with a dereferencing operator, because dereferencing operator returns a constant object, okay? So constant reverse begin and constant reverse end are added to the, so these four are added after C++ 11, okay? So whatever container you look at, okay, in this case it was that one, let's look at another one. Let's look at this array. Array is a new addition to STL library, okay? It says that, okay, I'm not going to be dynamic. At the beginning, you tell me my size, see the template. You say that I am an array of integers of size 100. It's like classical C arrays, okay? You cannot change its size, right, with the classical C arrays. You cannot change its size. Arrays is the same thing. You say that I have an array. Let's look at some example here. I don't have an example. Let's look at the constructor. Okay. If I click on one of them, I think I'm going to get one example. Let me look at the. Yeah. Okay. Okay. Good. So you say that I am an array of. Okay, I am an array of 5 integers, and it is fixed. Okay, it is fixed. So this is 5 integers. There is no growing, there is no shrinking. So if there is no growing and shrinking, this can be optimized very well, like the C arrays. And the thing is that the begin and end is always available for these kind of arrays, whether they are integer arrays or double arrays or whatever. So they have implemented this iterator stuff for the arrays. So let's see what kind of other things that we have in the array. And since we are most familiar with the class vector, let me open the vector first. Vector. Let's open the vector first. And this is the okay. So we talked about the vector boolean. It's just a specialization of it. And let's put it. Let me make another copy of this vector, and let me do it this way, and this one. Okay, I'm going to compare different types. So this the one on the left is a vector, make it a little bit bigger, and the one on the right will be our comparison. Let's compare this array with the vector right here. So array, let's look at the, okay, for the iterators, okay, for the iterators it is begin and it is all the same, right? It is all the same. Question for you, why didn't they put C++ 11 around here? You see C++ 11 tags here, but you don't have them here. Why didn't they put it?
Because that was added before C++.
No. See, before C++ 11 there were no C begin, C end. Because I mentioned it like 2 minutes ago, array is added to C++ 11. Okay, when C++ 11. So the whole array class is new to C++ 11. Okay, so all of them are new. That's why they don't have it. So with the capacity, you have the Size, yeah, that's it. And there is no capacity because the capacity is same as the size. And I have empty, and that's it. Okay. And element access is same. I can access everything. And modifiers, yeah. See, there is no pushback or pop back. Okay. There is no insert, there is no erase, there is no swap. Okay. Those kind of stuff. So all the dynamic stuff is taken away. So in a way that whatever this array has, vector has it. Vector is a generalized version of this array, maybe you could say that. So if they wanted, they would have derived this vector from array. Okay. So that's one comparison, and I think we were comparing lists with the vectors. I guess let's compare that too. List is a much more dynamic structure than the vectors. Let's look at this again. Iterators. Let's try to compare them. A little bit smaller. It looks like it is the same thing, right? So no difference for the iterators. Capacity thing, okay. How come I don't have a capacity for linked list? How come I don't have a capacity for linked list? What does capacity return for the vector? What is the difference between capacity and size? You guys are real, right? I am not dreaming this. So early in the morning. What is the difference between capacity and size? Can you tell me? Yeah, just maybe you can tell me. Yeah.
Capacity is located somewhere in memory, but size is element number.
The number of elements that you're using. So why don't you say it? Why do you keep quiet? So you can talk, obviously. Okay, capacity is the number of elements that I have reserved. Size is the number of elements that I am currently using. So size could be 0, capacity could be 100, right? For the linked list, we don't have such a thing, because for the linked list, any element you add will be added dynamically as a node. Okay, as a node, I will make a new node and I will add it to my list. Okay, that's how the list. That's why it doesn't make any sense to have a capacity for the linked list. Okay, so the element access is very limited, front or back. That's it. So how am I going to access the other elements of the linked list? Of course, you are going to use an iterator. Start from the beginning and iterate one by one. You don't have any index operators, okay? You don't have any ats, etc. These are the modifiers. Modifiers are, well, we are much richer than the other stuff, right? So I have this. What do we have other than this stuff? Yeah, we have push front and pop front. See, for the vectors, I don't have the push front and pop front, because if you push something at the beginning of the array, you have to shift all the elements. That would be an expensive thing. But for the linked list, it is no problem, because it is as easy as doing the pushback, pop back. Okay, good. Both of them have this mplace operation. mplace back. This one. Let's look at this mplace. It is added in the C++ 11. Mplace is this. It says that, okay, let's look at the definition. It says that I am going to take, okay, an R value reference. What does that mean? That means that you don't have to make a new object. I am going to use I am going to use the internal data of that object, kind of. Okay, let's look at this one. Okay, when you say and place back 100, it doesn't make any new integers. Okay, this 100 is directly pushed back at the end of the vector. For the integers, this doesn't make much difference. But for large objects, for example, you have a vector of vectors. If you are if you are using a pushback operation with a vector, that's going to cost you. But with this and place back, it's going to be very fast. So it is available after C++ 11. Okay, so you do this check. You just try to find other containers and try to compare them with our beloved vector class, and see what are the differences. We have list and forward list is a single linked list. Forward list, there is only a single linked list operation. List is double linked list. And we are going to talk about map. You know about queue. You know about the stack. Set is a set. Okay. Usually in C++ SCL library, you keep your elements sorted in a set, sorted in some way. But there is another version of it, unordered map. Okay, unordered map. It says that I am not going to keep my elements in sorted way. So this makes set even more efficient, because you don't have to keep them sorted. It is more efficient. Why? Because when you add a new element in it, you just add it. It is very fast to add, and it is very fast to ask if the element is in the stuff. So maybe just set is this. Set and set. It should be very similar to unordered set. Let me see if I can get it both side by side. This one and this one. Let me open the unordered set. Multiset means that I am going to allow the same element more than once in my set. Because usually the mathematical definition of set is, okay, mathematical definition of set is you allow one element only once. You cannot have the same element two times in the set, but multisets allow that one. So capacity iterators. Iterators are kind of, for the unordered set, iterators are kind of just begin and end. There is no R begin and R end, because there is no ordering, right, with the unordered sets. So it is giving you these elements just by random. You don't expect any sortedness. That's why there is no reverse, there is no forward. Okay, it is the same thing. Element lookup is find, count, equal, range. Well, they did not use the same order. Okay, so where is my find in this? Observers, yeah, operations. So they didn't use the same notation. Find, count, equal, range. Lower bound, upper bound again is about ordering. So the interface is very similar. Documentation is a little bit different though. Okay, so whatever, I mean, again, if I am making this in a hierarchy, which one would you put at the top? Which one would be a base class, unordered set or ordered set? Is an ordered set an ordered set? An ordered set is an ordered set. Well, you know what I mean. Which one is the base class, unordered set or the ordered set? Unordered is the base class, right? Because it is the more general behavior. With the ordered set, you are going to make it more specific. Now I am keeping all of my stuff. So whatever this unordered set has them, but it adds more stuff like the reverse iterators and upper bound, lower bound, the equal range, and etc. Okay, good. So let's go back to our slides. And I mean, so if we had a lecture about STL library, all you are going to do is just look at those elements one by one, and maybe just look at the iterators a little bit. That's what we are doing. So even though the STL is a very complicated piece of code, okay, it is large and there are lots of details of it. I mean, it is not a good idea to have a whole semester worth of course about STL. You are supposed to read it yourself. You are supposed to look at the documentation. You say that, okay, this is the data structure that I want to use. And in fact, for your next semester, when you take this data structures course, okay, you are going to each one of these is like a chapter. For example, list, you are going to start from the list. No, you are going to start from the arrays. It's going to be a chapter. List is another going to be a chapter. Then sets are going to be another chapter in the hash stuff. And there may be some specialized list like the trees. Trees are specialized list, okay? It's going to be another chapter, and maps are going to be another chapter. You will always talk about the stacks and the queues and etc. So each one is going to be another chapter. So that's where you are going to learn about these generic types, and you will learn them within the context of Java, not in C++. But you know where to come back to see the corresponding classes in C++. Okay. C++ does not organize these classes in a hierarchy, inheritance hierarchy. Okay, C++ doesn't do it. But Java does it that way. C++ says that, well, with the inheritance there is this efficiency issues. Every time I make a new object, it has to call the base classes constructor and it has to call the other base classes constructor. So originally 20 years ago, 25 years ago, they thought that it's not a good idea to have them in an organized in a hierarchy. So each one is a standalone class. They don't have any inheritance relationships between them. And that's what your next homework is going to be, okay? In your next homework, I will ask you to organize these classes in a hierarchy to make it work like. Of course, you are going to implement your stuff yourself, but it's going to be hierarchy, a sub-hierarchy, a hierarchy that contains some subset of these classes. Okay, so we talked about this. We talked about reverse iterators, and this is the vector integer. Okay, what is this? Okay, we talked about this. Okay, I have, for the vector class there is an inner class iterator. For the list class there is an inner class iterator. For the array class there is an inner class iterator. So each one has a different inner class. They are not the same classes. They are inner classes of the other stuff. Okay. Kinds of iterators. Okay. There are kinds of iterators. What do I mean by that? Some of the iterators can move forward, like plus plus will work for them. Okay. Some of the iterators can move plus plus minus minus forward and backwards. Some of them are good for the random access like this. For example, for the vector iterator, okay, you could say P2 or P plus 2 dereferenced. These are both okay. So the iterator of the vector class is the most general one. It can do forward movements, backwards movements, also the random access is like that. But for the list iterator, there is no random access. Okay? For the list iterator, there is no random access. Okay? And for the single list iterator, there is no random access and there is no minus minus operator defined. Understand? Okay? So those are the things. And those are things that you need to be aware of. Well, and how do you know about this? You just look at the documentation. For example, if you go to the list, and let's go to the list again, and just click on the one of the iterators. Again, begin. It returns an iterator. Oh, okay. Here are my iterators. Where is my iterator? Okay, iterators. It returns a bidirectional iterator. Okay. So bidirectional means that, okay, plus plus minus minus. Okay. And with the bidirectional iterators, you can do this stuff: plus plus minus minus, and etc. Okay. So that's the bidirectional iterators. Random access iterators are like this. They all are available, and these kind of stuff are available too, including the index operator. Okay. And forward iterators are only for plus plus. Okay. There is no minus minus or index access. So it looks like in C++ they have this nice hierarchy, okay, of iterators. There is input iterator. What is the input iterator? Input iterator is just plus plus, right? There is a dereferencing operator. What is the difference between forward iterator and input iterator? Let's see. Are iterators that can be used to access the sequence in a range that direction goes from beginning to end. Performing dereference never makes its value on that dereferenceable, non-dereferenceable. Did you see the difference between the? Maybe they can be constant iterators. Is that because there is a new class? Yeah, constant iterators are iterators that do not fulfill the requirements of output. Oh no. I didn't say it. Did you say it? Should we put them? No, I don't have time. Okay, it's your task to find the difference between the input iterator and the forward iterator. It looks to me they are the same thing. 1, 2, 3, 4, 5. Okay. Constructors equal plus plus. There is no comparison between them, right? Assignment, and if I do the same thing with input iterators, L value does not need to be assignable, okay? So there is a difference here. This L value type does not need to be assignable, so it makes it an assignable object. There is this dereference thing, is the L value does not need to be. So that's the difference. That's the difference, so we found it. Okay. So you just look at the documentation and see what kind of iterator that class supports. Okay. So vector has the most general type of most complex type of iterator. It can do almost anything that you like, including the forward, backward, index access, random access, and etc. Okay, so iterator classifications, we talked about those. Forward iterators, bidirectionals, and random access. And there are constant and mutable iterators. What does that mean? Well, remember the constant iterator, C begin, it returns a constant iterator. With the constant iterator, dereferencing doesn't return you an L value, so it is going to be writing something is illegal for the constant iterator, so that's what we already know. Reverse iterator, we talked about it. So this is used for beginning, from the beginning to the end, okay? So, sorry. Don't write this kind of code. Because remember what I said before, let's say if this is my vector, okay, begin, iterator, the function begin for vector class will return an iterator to the first element of the container and will return this. So you cannot say that I am going to start from the end and I will decrement it one by one and I will stop when it is begin. For some compilers this works somehow, but don't write this. This is not a standard code because at the beginning end is pointing to something, someplace that is not valid if you do this dereferencing. So what are you going to do if you do it with the reverse? You are going to ask for the reverse begin, okay? You are going to ask for reverse begin, and your iterator is an reverse iterator, okay? So each class defines this reverse operators, if it's a bidirectional class, of course. List class defines it, vector defines it, but single link class doesn't define it. Okay, so our begin and our end, and of course, since it's a reverse iterator, when you do plus plus, it goes backwards because it's a reverse iterator. Okay, so that's another thing. As always, C++ is a complicated language and it is not easy for the compilers to implement all the features of it. Sometimes you get error messages that you don't expect. Remember, I got an error message with this leave C++. Where was it? I think I erased it. There was a type definition or something at the beginning, I forgot. Let me try to, can I do this? Yeah. If I wanted to compile this, I think I got an error message. It said something. Let me try to get that error message. Yeah. Iterator was not declared in the scope. It is saying something that I don't know why it is doing. Probably it is a buggy compiler. It didn't implement something. So to get away from this problem, what did we do? I think we did this. And instead of iterator P, I just put this auto keyword here and get rid of this one. And I think that's what, and auto here. Even though we did not do anything bad with that code, it did not compile. This is an equivalent code. Now it compiles. So our point is, some compilers problematic with iterator declarations, and that's one of those compilers. Okay. So you are doing everything right. Your compiler doesn't compile. What are you going to do? I quit. I did my job, and it is the compiler's fault. Do you think your boss is going to pay your salary in that case? No, of course not. You will get fired because you didn't complete your task. You are going to find a solution. Okay. Solution is just try other stuff. Okay. This is a nice compiler, and most of the time, well, I mean, nowadays it is happening less and less. Sometimes you get a crash from the compiler. When you are compiling your code, okay, compiler crashes. It just says that I am terminating, I couldn't do this. Okay, compiler crashes. So what are you going to do when the compiler crashes? You change your code a little bit so that your code is simpler. Okay. You divide your line of code into multiple lines and make the few function calls and etc. And this is one of those cases. Okay, so that's what the book says. If something should work and it doesn't work, what are you going to do? You just change, write it in a different way, and it should work. Okay. And auto is very valuable for us. Instead of writing this whole lengthy line of vector iterator has a vector int has an iterator inner class in it, and I am going to declare one object of it. No, you don't say that. V begin returns something. Whatever it returns, deduce it, and P is of that type. Whatever V begin returns, just P is that type. Whatever V dot R begin returns, P is that type. Okay, that's it. Okay, and when it comes to constant reverse iterators, when you say VRC begin, well, I mean, the type of that iterator is maybe longer than a single line type, so we don't do that with C++11. Very convenient. Okay. So let's look at this container classes. We already did that actually. Okay, we have the vectors, and we have the list, and we have the single list. We have now arrays, we have sets and everything. And we are going to look at them maybe one by one, a few of them, but not all of them. Okay. Sequential containers. Okay. The one that we use most of them is the vector. Vector is a sequential container. Why? Because there is a sequence in it, right? There is an order. You talk about the first element, next element, next element. These are the sequential containers. Sets, unordered sets or maps, they are not sequential. Okay? They can keep their data in any sequence they want. They don't have to specify a sequence to it. Okay? It says STL doesn't have any single linked list, but C++11 has it, single list, or you call it forward list. Okay? Why would you use a single list instead of a double list if you have both of them? Double list is the better one, right? I can go forward and backward. Why would you use a single list instead of a double list? Why did they add it in C++11? What was the complaint? Some people complain that we need a single list. Double list is such bad and bad. What was the complaint about the double linked list?
I think it's related to memory efficiency.
Memory efficiency is the correct complaint, yes. Because, I mean, if I'm not going to use the backward links, why do I keep them in my memory? Okay, it's a waste of memory, especially if I have a linked list of integers. Integer is a very small thing, okay? In a given single node, this is my integer, and this is my pointer, okay? So 4 bytes plus 4 bytes is 8 bytes is good, but if I keep doing this, 4 bytes integer, 4 bytes forward link, 4 bytes backward link, so it makes 12 bytes. It's like 50% more memory for this linked list if I'm going to make it a double linked list. Okay, it's exactly what our classmate said. Memory efficiency is the reason why we have single linked lists. Good. Okay, so we talked about this. I guess it is a good picture. Begin points to this one, end points to here. Okay, that's why you don't start with an end. If you like to do the reverse iteration thing, you should have an R end. Of course, R end will not work for the forward linked list. Okay, so if you need to go back both ways, you are going to use a linked list, double linked list, not forward list. So there is nothing interesting here. We already did that. Okay, so I could have written the same code with a vector, right? Exactly, because it uses just push back. It doesn't use push front. Yeah. Okay. So I will move on. Good. So those are the type of container classes, vectors and lists and arrays and etc. You know them. Okay, so let's look at this specific special classes, stacks and queues, and we are going to call them container adapter classes, stack and queue. Why do we call them container adapters? I mean, stack by itself, what does a stack do? It has just push operation, pop operation, and empty, right? That's it. There is no fourth essential function that you need to implement. You just, this is my stack. I push elements like stack of integers. I push 1, I push 2, I push 3, right? That's it. And if I like to pop, I just pop 3, then pop 2, and pop 1. And the third one is, are you empty? I ask a question, empty. That's it. These are all the operations, okay? So how would you implement this? How would you implement this class stack? Okay, just add these 3 functions and do what else? Nothing, right? How would you implement it? What would be your private data? You are free to choose anything you like. What would be your private data?
the variable or something like that.
What's that?
Top of the number or something like that.
What else? I mean, what would be your main data structure?
Last input.
What?
Last added value. I'll say last added value.
But where do you keep your 1, 2, 3, 4, 5? That's what I'm asking. What would be the main data structure that you are using? Remember we write PF array, right? Partial field array.
Yes.
What was our main data structure? It's about the pointer array, right? Integer pointer or the double pointer, whatever. Okay. So what are you going to use now? Are you going to use a pointer to some variable and dynamically allocate it? And is that what you're going to do? Well, it could be possible. I mean, you would say a T pointer, okay, at the top of the stack, maybe a pointer that points to the top of the stack. And every time I get a new element, I have a push, I reallocate space and put one more on it and copy the whole thing. That would be very, very inefficient and very, very unnecessary because I already have it. So for me, I think I would have used just a vector. I would use a vector T as my private data. Okay, if somebody says push this, okay, I just use the pushback operation. It says pop, I just use the pop back operation. For the empty, I would check if the size is 0. That's it. Okay, so I didn't write anything new. I just used somebody else's capabilities. Okay, so these kind of classes are called adapter containers. Okay, container adapters. I just use somebody else's capabilities to implement myself. Okay, and in fact, the stack is declared this way. I need an integer stack, and I am going to use an integer vector as my internal data structure. This is how you make a new stack. Of integers. Okay, you are specifying to the compiler that okay, I am an integer stack, but as an internal data structure, I am going to use this class. Okay, I am going to use this class, and of course, this guy says that don't forget this space. If you forget that space, you will get an error message. But with C++ 11, okay. If you like, you can put these together, so the compiler will not say anything. So you can forget you may forget the space between those brackets in C++ 11. Okay, so these are called container adapters, and stacks and queues are like those. Okay, if we look at the definition or the documentation of the stack. Where is my containers? Let's look at the stack. And stack says that if I come on. Okay, stack says that. Okay, so templated class. And container is a container. I am a container adapter, right? I am a container adapter. I am using a dig class. Okay. This dig class is like a bit. It is dig is a data structure that is in between a list and a vector. So it behaves both like a list and like a vector too. So it is kind of in between, so you're going to see this in your data structures code as well. Just read it, okay? So these are the things that it has. It has, okay, pushback, pop back. What is your size? Are you empty? And give me, it's like, it's not pop back, but it is back. What's the difference? Pop back pops it, back doesn't back it. Back doesn't pop it, okay? Back is a constant function. So pushback and popback are not constants. Okay. So I think last year I have implemented this class, right? Yeah. Okay. Here it is. This is the whole implementation. Template, class T, class R. Okay. Class R is my default class is sorry, this has to be, there's something wrong here. This has to be T, okay? And in my private data, I have R data. For the push operation, I get a constant T reference object, and I just call data.pushback E, and my pop returns a T. I just return whatever this data.popback, and boolean empty, I just check the size of data. If it is 0, I return true, otherwise it is false. And it has to be a function call. I forget about the function call. Okay, good. So this is the whole implementation of the stack. This, and in fact, these adapter classes are a principle of object-oriented design. Okay, object-oriented design philosophy, and this is called a pattern, actually, örüntü in Turkish. So when you say that I implemented this class as an adapter, okay, adapter class, it's an adapter class, so everybody knows what you are talking about. So adapter of what? It's an adapter of vector, okay? It's an adapter, container adapter.
So
You adapt something for you to work it for your sake. So there is no is-a relationship between vector and stack, right? There is a composition has a relationship, and you are telling the compiler that I am using this as a relationship when you are compiling it. So this is okay when you say, I have a stack of integers. I have a stack of integers, but I am going to use a list for this one. But if you say, I have a stack of integers, as a container I am going to use money, this will not work. Why? Because the class money doesn't have pushback operation, popback operation, and the size operation, right? So this will not work. Do you think this would work? Stack, integer, array, integer. Stack, integer, array, integer. Do you think this will compile? No, why not? Because array doesn't have pushback, popback, right? Array is static. This will not work either. So for the adapters, okay, you need to put the correct class in there. Okay. Somebody had a question? You had a question? Yes.
Stack is like derived class of vector, right?
For the second line, you mean this one?
No, stack is like derived class of vector.
They are?
Derived class of vector. Derived.
No. No. Did I say that? No. Do you see anything like public vector? No. It is not. Where did you get that idea?
No, not the implementation, just the idea.
Well, stack is not a vector, right? Stack, I mean, when you make a stack a vector, then all the indexing is available for you. First element, second element, third element, right?
Yeah.
That would be a bad thing for a stack, right? Stack is not a vector, okay? Stack may contain a vector, maybe has a relationship, but there should not be a relationship between stack and vector, okay? So what is available other than that? Okay, so that's it. Well, it looks like I don't have a iterator, right? I have empty size, top, push, pop, and place, and swap, and that's it. I don't have iterators for this class stack, and which is kind of makes sense. Okay, and as we said, okay, this is by default, this is dig. Okay, good. Where is Q? Where is dig? Dig is here. Okay. So did I click? Okay. Let's see what the dig says in its irregular acronym for double-ended queue. Okay. Double-ended queues are sequence containers with dynamic sizes that can be expanded, contracted on both ends. Okay, so it's a queue but double-ended queue. So what are the stuff? What kind of things can I do with them? All the iterators. Okay. Reverse iterators are there. Yeah, see? Operator index is available. Pushback and push front is available too. As I said, it's like a vector, but I can place anything that I like anywhere. Okay, I don't know how they implement it. Maybe if you read the documentation, you will see it. Okay, any questions so far? Any questions? If there are no questions, then I will take some break, and after the break, we will talk about associative containers. Okay, let's be here around 9:41. Okay, and I will bring your attendance when I come back. Bu kimin olabilir ya arkadaşlar? Tanıyan var mı bunu? Ben o laptop hikayesi. Hocalardan birinin mi acaba? Burada Erdoğan Hoca mı yapıyordu ya şeyi? Neyse ben bir e-mail atayım bakayım. Okay, so with the associative containers, we will generalize the idea of indexing a little bit. Up to now, we did stuff like that. If you talk about the arrays and vectors, etc., we said that if I have a vector, A, give me the seventh element. That's what we said, and we can do anything we want, including assigning some values to it. So the idea is this: I am associating this index with this value. So it's like let me make this a vector of strings. I am putting the string A, B, C at this position 7. I could say, maybe you can say 7 A, B, C, and 3 a name Ahmed. Okay, I could do that. So the idea is, why can't I choose another type for this indexing? Why can't I say, okay, A, for example, A index Ahmed, okay, guess the value of Mehmet. Why can't I say that? Okay, why can't I say this? So these are called associative containers. You associate one key value, one key with a value. Okay, this is the key, this is the value. Okay, key and value. So I have been using this, but I have been using this with a integer all the time. Now I like to use different types, including the strings, or doubles, or many objects, or other vectors, and etc. Okay, so this is called associative container. So each data item has a key. This is the key, and this is the value. So key value pairs. Okay, so key value pairs. For example, a social security number could be your key, or TC kimlik numarası, and your value could be your data. That's called the associative containers. And the simplest associative container is the set. With the set, in your key part, you don't use anything. Okay, your key part doesn't include anything, so you have only your value part. We will come to set in a few minutes, but let's talk about the more general type of associative containers, map. So you are saying that I have a map, it's called a number map. My key will be string and my value will be integer. Or I could be, my key will be a string, my value will be a person, whatever that person is. Let's look at this example here. Okay, I have a string map. Okay, it's called this planets. And as you see, right after doing this, I keep adding stuff. We are going to talk about the planets. So Mercury gets the hot planet, description value, this is key and this is value. For Venus and Earth and Mars and Jupiter, it goes that way. Okay. So as you see, you don't say, I am adding this, and I have this many maps and etc. You just keep adding them, and it handles it. Okay, so the data, the data structure behind this is something that you don't know yet. It's called. Did everybody sign it? No. Okay. So the data structure behind this is called a hash map. Hash map, and next semester, your data structure course instructor will talk about this hash maps. Okay, so we will currently ignore that, but it works this way. It is you don't need to say, I am adding a new stuff. I am doing this and that, etc. You just say, I am adding this pair. Okay, an index operator here. Again, this is string. It would have been a double string or money string, money, etc. Or array. Doesn't matter what it is. It will handle it in an efficient way. So after I added these, let's look at what we are doing. Of course, this is a container, and I can run a constant iterator on it. So when I say planets begin, okay, give me an iterator. It's a constant iterator in this case. And I can iterate over all the things. And as you see, for all the elements of this planet's map, I have my first and second element, because, you know, this is two things. This is the first and this is the second. Okay, so the iterators work. So I am going to use my iterator notation, like the point notation. I can do whatever I want. Or you can use the member function find. Inside this planets container object, find this Mercury. Okay, find works this way. If it finds it, it will return an iterator to that position. If it doesn't find it, okay, it will return an iterator to the planets.end iterator position. So I just call find, planets.find, Mercury. It's going to return me an iterator. I compare that iterator. If it's not end, then I found it. Okay, then I found it. Otherwise, I said I did not find it. Okay. And this one is nice too. Did you see this? Entry for Mercury is planet Mercury. Index operator works. I wonder what happens if Mercury is not in the. Mercury is not in the. Let's go to this one. What is this? This is example number. I don't know what is it. Let me open this one with our. What is this? Stack. Okay. Set map. Yeah. Okay. So I wonder if this is not in the set. It is not in the map. I think this may throw an exception. Let's go to the documentation. Documentation for the map. Look at the look at the index operator, the access element of it. What does it return? I mean, the definition might be exactly the same thing. Okay. Okay. Oh, okay. If k does not match the key of an element in the container, the function inserts a new element with that key and returns a reference to its map value. So if it is not in there, it just inserts a new one and returns that value. So you assign something, and it will work. That's what happens. So there is no exception throwing or anything like that. Okay. So A, B, C. How about this D is going to return what? For A I have this one, for B I have this one, for C I have this one, for D I don't have anything. Let's run this one. Okay, run it. Okay, as you see, my map D is empty because I did not do anything. I did not insert anything. So it's a null string. It doesn't have anything. So this one will never throw an exception or will fail. If it is not in there, just insert it and the value part will be empty. Just a string, default constructor string. Okay, so this is a map of character and strings. Good. So that's called a map, associative container. So if you just ignore the first part of it, this key part, so it becomes a set. That's what set is. Set is a specialized associative container. Okay, it behaves like a set, as the name implies, like a küme. Okay, simplest container possible, because all you do is just add elements and delete elements and ask if element is in the set. Okay, and of course with the set you don't have any random access. I don't think that you have any random access. Well, since set is ordered, maybe you may have it. Let me see if you have. Okay, go to set. See what kind of modifiers, iterators. Yeah, fine. No, I don't have indexing operator. Although it is sorted, indexing is not implemented. It doesn't make much sense for the set. Okay, so add element, delete element, ask if the element is in the set. And you may specify this ordering relationship too with a added parameter to the template header. You can specify the ordering. So how are you gonna order these elements? I mean, you don't have to order them using. For example, if you have a order of, let's say, order of, if you have a set of integers, okay? I know how to order integers. I mean, the less than greater than sign works for the integers we know, but I don't want to use our regular ordering criteria. I want to use, for example, I want to use the dictionary ordering. What's the dictionary ordering? In dictionary ordering, it's like A comes first, and AA comes later, right? You know that's right. Then A, B, C, for example. This is dictionary ordering. So if I do this dictionary with the integers, this is 1, 1, 1, 1, 2, 3. It goes like that. Okay. So this is the dictionary ordering, and I can if I like I can do the dictionary ordering with a set. So you change this ordering parameter. So you say that I don't want regular integer ordering or the sorting. I want the other type of sorting. I am going to give it to you as a parameter to this template, and we can change it if you like. And how are we gonna change it? You can look up the documentation. I am not going to look at it right now. Okay, and this is one example. Set of characters. I inserted this A and D, C and C. So how many elements do you think this set has now? 1, 2, 3, 4, 5, 6. Just 1, 2, 3, 4, right? A, B, C, D, because I am inserting the C more than once. So because this is not a multi-set, this is a regular set, and it is inserted. And I get an iterator, okay? And I started from the beginning, and I am iterating towards the end, and I print them one by one to the screen, okay? And what else? Then I am going to ask this question again. Is element C in the set? If the answer is yes, okay, then I am not going to get this S dot and iterator back. I am going to get an iterator to the element itself, okay? So this find returns an iterator. Find returns an iterator. Let's go look at the documentation of find. Here it is. Okay. Find returns an iterator or constant iterator. Okay. Depending on your called function. And you can check if it is and C and or itself. Okay. So this one, my set, there is an iterator in it. It inserts 10 elements, if 5 elements, 10, 20, up to 50. Iterator find 20. See, find 20 inside this set for me. Once it finds it, I just erase it. My set dot erase iterator. So iterator is pointing to a element that I am just erasing it. Also, I am erasing the 42. And after that, I iterate over all of my elements one by one, and I print them out. By the way, remember our range for loop? Our range for loop works for all kinds of containers as long as they define an iterator. Okay, let me compile and run this. Run. So my set contains now 10, 30, and 50. Okay. So, but at the beginning, okay, when you say for this auto is very nice. Auto I and my set cout I, and don't forget my backslash and character if I can find it. Okay, good. Okay, so It will work for my, I mean, whatever my container is, this range for loop will work as long as that container offers these iterators. Okay, so let me run this one. It didn't like the cout because I didn't specify that. Okay, so it gave me the result, 10, 20, 30, 40, 50. Okay, so it works. It works. So very, very convenient way of iterating over all of my elements one by one using the range for loop. It works for the sets, it works for the integer, for the vectors, lists, and as I said before, as long as you have the iterator, forward iterator. Good. Okay, and it works this way. So map is a specialization of the set. Set is just opposite. Set is a specialization of the map. You just ignore the first element of that template definition, okay, for the sets. So the most general version of the sets are maps. So they just associate this one with this one, this key with this value. So for the sets, you just have the key, you don't have the value, okay? You just have the, did I just say the opposite? Well, I was wrong, I said that you ignore the first part. Ignore the second part. For the set, you just have the key, you don't have the value, okay? So set is if I had the hierarchy, map is the general one, set just ignores the second one. It says I don't have I am a specialized map, I don't have the value part of it. I just have the key, okay? I just have the key. Okay, good. So this is the map. And I think, yeah, this one is talking about what I told you before. Okay, with the C++ additions, you may initialize your containers like this, for example, like that. I have a map of integer string pairs, and I will add two elements in it. One is 1, volt. Second is 2, Kenrick. Okay. And another one is a set of strings. I will add these three. So the regular array initialization works for the vectors or sets or maps or linked list or whatever you want, as long as they define these iterators. And of course, this range for loop will work for any kind of containers, as long as I said, that container has the iterators defined. So with C++ 11, use these kind of tricks. Yeah, you can use it. That makes your programs more readable. Okay, much readable. I mean, this is much more readable. This is, where did it go? Oh, okay, here it is. Okay, this is much more readable than this one, right? Okay. How about this one? What do you think that I will get out of this? Now maybe I should do this. This is an integer, right? Are these integers? Yeah. Okay. What would be the output of this program?
Garbage food.
It is exactly the same, right? How about this? How about this? Or maybe this. Would this work? What am I doing here now? Would this compile? It should compile. Why not? Because I is an integer reference. It's not a constant integer reference. And I becoming a reference to each of my set elements, right? And I am just modifying them one by one. Let's see what it does. Oh, okay, invalid is, okay. Type const integer. Okay, so it looks like my iterator here on this one is returning me a constant integer reference. So I cannot modify them. But if I had a vector or something, for the vector it works. So because it returns a constant, okay? Yeah, it returns a constant integer reference, not an integer reference. That's why it doesn't work. So it looks like they made it impossible to modify the elements of set this way, because if I modify the position, the value of set is position within the set is going to change. I am changing the ordering, right? But I'm sure I can do the same thing with a vector, and it's going to work. Let's make a vector. Vector of integers, and let's say I have 10 elements in it. And I am going to do this. Okay? Let me make this go away and run. Our vector didn't like the name vector because I didn't use this name, and I didn't use vector here. Did I get the same error again? What? Oh, okay. This is my set. Yeah, that's because, again, that's the problem. It says you cannot get, okay, so it just printed 1, 1, 1, 1 because it is as initialized to 0, 0, 0, and it works. So this one works for my vector, incremented, but this one will not. And to make this work like that, okay, so I don't know what that is, and run it again, did it say something bad to my, what did it say? Has an external warning 21. Where is 21? Where is the first? Okay, this is the 14. So what is wrong with this? That's because when I do this parentheses, it means that I am defining a function, right? You don't say, how do you define a money? Money M, right? You don't say money like that. What does it mean? M is a function that doesn't take a parameters, and it returns a money, right? That's what I said in that case, because I forgot to remove the stuff. Okay, and get this and run it again. Okay, so it incremented all of these values one by one. It became 3, 4, 5, 6, okay, and 54 became 55. Maybe you don't see it here, okay. So just do this kind of games with the compilers, okay? Play with the what can happen, what doesn't happen, and that will teach you a lot. That will teach you a lot. And I didn't know that from top of my head. You cannot get a non-constant reference to the elements of the set. Now I realize that if you modify the elements of a set, it changes its position, right? Because it's an ordered set. Okay? Maybe for the unordered sets, I think you can get a non-const reference, because ordering doesn't mean much for the unordered sets. I am not sure. Okay? You need to just test it or look at the documentation. Okay, let's go back and let's talk about, skip these parts because this big notation and everything is just your topic for the next semester. Let's talk about these generic functions. In C++, STL specifies lots of algorithms for you. They are some of them are very nice. Let's look at the other stuff, the algorithm, okay? So they are all templated functions. We don't like functions, but they are available, so why not use them, okay? Some of them are about sorting, for example, see this one, see? You just call sort, okay? You just call sort on one of the containers and it will work. Let's look at the documentation. So sort says that, okay, I am a templated function, okay, sort. I will take two iterators, beginning of the vector, beginning of the container element, and the end of the beginning of the container iterator, beginning of the container position, and the ending of the container position, and I will sort in between. Okay, so for that one, I need a random access iterator, like the vector or array, etc. Okay, so first to last. So let's see this example. Okay, my main integers, I have these integers. My vector is initialized with using integers, 8 of them. And I call sort. So my vector begin and my vector begin plus 4. I'm going to sort just 4 elements of it, 5 elements of it. Okay? Just 5 elements of it is sorted, those integers. Okay? If I don't want to sort the integers with respect to natural ordering, I can add another function, a function pointer. Okay? So it will perform the sorting with respect to this function. This function is this, okay? Bool, my function, it takes 2 integers and it says I'm returning true if I is less than j, okay? So I am sending a function pointer and it will work for the sort, okay? Or there is a third overload. It takes a comparison object. Comparison object is this, it's a class. Inside that class there is operator parentheses. It will take 2 parameters and return I is less than j. So it's just another way of specifying the sorting order. Okay. So the sort function works this way. You specify 2 iterators, and between those 2 iterators, like 2 pointers, it is sorted with respect to natural ordering or the ordering specified by this function pointer or this ordering object. That's what these stuff say, okay? Random access iterator or random access iterator and the ordering function or the class compare. Okay? Good. So this is just a sort. What else? What kind of other stuff do we have inside this algorithm? Let's go back to the algorithm again. Many things you can do. Just take a look at it. For example, what else? You don't know about the heaps. You learn about them. Copying of elements between the containers within the same container. it can be done using this copy function. Find and search is going to work. You are going to say find something, do this. This for each is interesting. Let's look at this for each. For each does this. Well, in fact, this is the implementation. Yeah, this is the for each implementation. Okay. For each, input iterator first, input iterator last, and function fn. I mean, there must be a function to work on it. So this is input iterator. That is the most general kind of iterator. Okay. So in a container between these two iterators, okay, just call this function fn. So this function is going to be passed. Function is going to be passed as a parameter, and this will work. So this is the whole implementation itself. This is just for each. That's the implementation. Well, I mean, the exact implementation may not be like this because sometimes there are some optimizations, but behavior of this template is equivalent, it says. It's not okay. So let's look at some example. Okay, my class, there is a operator parentheses function. It takes an integer and it just prints the integer out. Okay, so I have a vector of integers. I am calling this for each function. From beginning to the end, for each of my elements, call my function. Okay, for each of my elements, call my function. And this iterator does not depend on vectors, right? It could be a iterator of sets, iterator of unordered sets, iterator of maps, iterator of whatever, okay? So all you need to specify this my function. Very, very generic, very, very generic code. Okay? And most of the time, all these algorithms that are defined inside STL, okay, very efficiently implemented. They are very robust, and you can safely use them. And when you use them, people, whoever is reading your code, since they know about the STL2, they can understand what you are doing. And most of the time, for this kind of generic stuff, you don't have to implement anything. Okay? Good. So interesting stuff here. What else? Field, generate, remove, unique, make everything unique, reverse it, rotate it. Okay? Partition stuff, sorting stuff. I think the sorting is implemented using quick sort and what kind of sorting is exceptions, complexity. Okay, the complexity is this. On average, linear, it make any distance between first and last. Performs approximately n log n. Okay, so it looks like it is doing merge sort. It is not average, it is approximately, so it is doing merge sort, it looks like. But it doesn't make any promises about I am doing this kind of sort. It just says I am doing approximately n log n. Okay, that's it. It doesn't say anything about the type of the sorting algorithm. It doesn't make any promise. So in the next iteration of this STL, they may switch their algorithms. Good. So if I go back to my slides again, we talked about this modifying set algorithms and sorting algorithms and etc. I guess that's all I want to talk about now. And that will end my discussion about STL. So I mean, I didn't say many neat things actually. All we did today, we went to the documentation and we read the documentation. So STL programming means that reading the documentation, doing some experiments. So I only introduced this idea of iterators, but you may have guessed it already because iterator is a new class that behaves like a pointer. It overloads the dereferencing operator, plus plus operator, minus minus operator, less than greater than stuff. That's it. Okay. So maybe this was a good exercise for us to kind of think about what kind of classes should I design and implement. Each of those classes are nicely designed and implemented: vector class, set class, map class, and etc. Each of those generic algorithms are nicely designed and documented. So that was it. So in terms of object-oriented programming, or in terms of C++ programming, I didn't say anything new today. All the things that about C++ I told you, you already knew. This was just good examples of C++ code, C++ libraries. Okay? And definitely I didn't say all the things that are sayable about the STL. STL is much larger than what I am talking about here. There are many more classes, there are many more details. And most of the time, I don't remember it. I mean, I didn't remember that the set did not return a reference, okay? Non-const reference. It returns a constant reference. It makes sense after you think about it. So you are going to make these kind of mistakes all the time. So what is the solution? You do lots of practice and you read the documentation a lot. Okay? Good, any questions? Any questions from the online audience? Did I get my attendance, people? Okay, on Monday, we will start talking about Java. Okay? For the Java, as I said before, I will assume that you are better than average C++ programmers. You know everything about the C++ programming language. And I assume that you read all the stuff in your book, textbook, other than the linked list and the dynamic structures, data structures chapter. That chapter doesn't give you anything. I think it is not any more detailed than the STL chapter anyway. So I assume that you know everything about C++, and that way it's going to be very fast, and I'm going to talk about only the differences between Java and C++. That's going to make you understand, realize the features of C++ better when you do the comparison. But also at the same time you are learning a new language too. So it's going to be interesting for you, but without knowing C++, you won't understand C much. So that means that by Monday, just make a review of this language C++, and you will realize that you did not exactly understand some of the topics on C++ when you do the review. And when we start talking about Java, things will sit much better in your head about C++ and Java and object-oriented programming. So I'll see you on Monday. And so when was your homework due? Did we miss it already? When was the due date for the homework? Homework number 5? Today?
Yes.
Today. So for the bonus, you have a few more days. Okay. So on Monday, maybe I should give you your last homework about C++, which is going to be about a hierarchy of the containers and array and vectors and sets and iterators. I did not decide it yet. Of course, you should use C++ 11 features like the move semantics and that kind of stuff too. And after that, I will assign you 2 more homeworks, and they will be about Java. Okay? Good. See you on Monday.